I'm excited to welcome you to the absolute best explanation of rems and ems you'll find anywhere on YouTube. In this video, I use interactive animations to explain the theory, covering everything you need to know in detail, as well as a step-by-step walkthrough of its application in a real-world web application. So let's jump in. So what are rems? Rems are a unit that is relative to the root element's font size and are the key ingredient for creating responsive web pages. Now, before we dive in, I just want to highlight rems are really important. They are the primary driving force of making our pages responsive. That is, scaling our content for different screen sizes. So this sentence may not be the clearest, so let's break it down. We'll be talking about the root element first. As a reminder, in our HTML document, we have this HTML tag, which we call the root element. In my HTML full course, which you can join for free on YouTube, I spend a chapter on HTML document structure. And you can see over here are these HTML tags. This is the root HTML element, which wraps all other elements. It's the same as a book cover wrapping all the pages. In HTML, it's the tags that wrap all the other content. Now, the font size of the root element is 16 pixels. And what we're going to see now is that we can size different elements based on the root element's font size of 16 pixels. So let's look at an example of this. I've got over here an anchor tag with different properties. The first property is the font size of the anchor tag, which is currently set to 2 rems. So this font size would be 2 times 16 pixels, which equals 32 pixels. Again, the 16 pixels is coming from the root element's font size, which is 16 pixels. We can also use rems on non-font size properties. So for example, the padding of this anchor tag is currently 0.5 rems, which would be equal to 0.5 times 16 pixels times 8 pixels. Again, the 16 pixels is coming from the HTML root element, which has a default font size of 16 pixels. The last declaration, margin bottom, has a value of 3 rems. This is 3 times 16 pixels, which is 48 pixels. Alright, so you're probably thinking right now, this is just really confusing. What is all this extra work of using this rem value, which is dependent on the root element's font size, and then I've got to multiply numbers by it? Why can't I just put my values like 32 pixels, 8 pixels, and 48 pixels? And I agree with you, it does seem really confusing. But let's go play around in VS Code to get a taste of why rems is so powerful. Alright, I've gone ahead and created this index.html file. I've got an h1, a paragraph, and an anchor tag. I've also linked a style sheet, which is currently empty. So let's head over to app.css and add some rem values to our different properties. I'm going to select the h1. Let's apply a font size of 3 rems, which again is 3 times 16 pixels, which would be 48 pixels. Let's apply a margin bottom of 2 rems, which is 2 times 16 pixels, or 32 pixels. Let's grab our paragraph. We'll give it a font size of 1.5 rems, so 1.5 times 16 pixels, which would be 24 pixels. We'll give it a margin bottom of 1 rem, so 16 pixels. I will grab the anchor tag. We'll give it a padding of 2 rems, which is 32 pixels. Let's give it a background color of light blue. And just so that the padding applies correctly, we're going to change the display property to inline block. And just as a quick reminder, that's because an anchor tag is an inline element, and for box model properties like padding to apply properly, we need to change it to inline block. If you don't know about inline block, you can check out my video in the description below. Alright, so let's check this out in the browser. So you can see the different elements over here. Let's open up DevTools, and let's inspect the heading. You can see it has a font size of 3 rems and a margin bottom of 2 rems. Looking at the box model down here, you can see the margin bottom is 32 pixels, 2 times 16 pixels. If I head over to computed, you can see the font size is 48 pixels, which is 3 times 16 pixels. And again, just to really drive the point home, all of these values are being calculated off the root element's font size. The default font size of the root element over here is 16 pixels. So we can actually change this value. Just to show you this, if I make some space here, select the root HTML element and give it a font size of 16 pixels, I'll refresh and you'll see nothing happens. And that's because the default font size of the root element is 16 pixels. Now, as I mentioned earlier, I do want to give a bit of a taste of why REMs is so powerful, because at the moment, it just seems like a lot of work. In a later topic, we're going to be learning about media queries. And what media queries allow you to do is apply styling for specific widths of your page, which can be used for specific screen sizes, like mobile, tablets, and desktops. So for different screen sizes, what we're going to do is actually change the font size of the HTML root element. So for example, on a mobile, we might want our root element's font size to actually be 8 pixels. If I refresh the page, our font size, margin, and padding all dynamically updates by changing a single value. That is, the font size of the root HTML element. And for larger screens, we might set it to a value like 20 pixels. I'll refresh, and you'll see all the values dynamically update, all based off the root font size. All right, I'm just going to go change this back to the default font size of 16 pixels. Now, the default root element font size of 16 pixels is not the nicest value to work with, but let's go and see how we can make our lives a bit easier. Working with a base 10 pixels for REM units makes it simpler when thinking about sizing elements. My advanced maths is pretty good, but my basic maths sucks. So when I'm thinking of values, to have 16 as my base unit to multiply with fries my brain a bit, but 10 pixels is much easier to work with. So what we can do is inside our CSS file, we can select the HTML root element, so it's fixed at 10 pixels, which means one rem now equals 10 pixels. So let's go add this in VS Code. So I'm back inside our app.css file, and I'm just going to go update the root HTML font size to 10 pixels. I'll refresh, and you can see straight away all these elements adjust. Now the font size is 3 times 10, which is 30 pixels. Just so that we can use this new value, let's go change the font size to be 5 rems, which would be 5 times 10 or 50 pixels. Let's go open up DevTools just to confirm this is the case. I'll select the heading. You can see a font size of 5 rems. Heading over to Computed, we can see a font size of 50 pixels. I can also confirm on the HTML root element, we can see the font size of 10 pixels. And if I go to Computed, the font size is 10 pixels. So that's now the base unit we're working with. Now, working with 10 pixels is certainly a lot better, but we do need to account for one more thing. What I want to show you is that your browser has a default font size it's using. Inside Chrome, I'm going to click these 3 dots. I'm going to head over to Settings. I'm going to go to Appearance, and you can see over here font size. This is currently set to medium, which is recommended. Now, medium is 16 pixels. Looking at some other values, very small is 9 pixels, small is 12 pixels, large is 18 pixels, and very large is 24 pixels. Now, I just leave my screen at medium, but whenever I grab my mum's laptop or phone, the text is seriously massive. It takes about 10 times longer to scroll through a page when looking at something on her phone. So to make it easier for her to read, she's using large or very large as her font size. Now, the problem with setting font size at 10 pixels overrides those font sizes in the browser, which means that if someone were to go adjust the font size in their browser, like my mum, it just wouldn't scale accordingly. So to fix this, we instead set a font size of 62.5%. So where does this number come from? Well, we want our font size to be 10 pixels. All I've done is divide 10 by 16, which is 62.5%. 10 pixels is the value we want for a medium screen, but in the browser, the medium screen is set at 16 pixels. So what I'm doing is I'm effectively taking 16 pixels, which is the browser's font size, and multiplying that by 62.5%, which then gives me 10 pixels. And using a percentage value like this means we can use the different font sizes and just apply 62.5% to each of them. So this will scale if the user updates their browser font size. Looking at some mathematical examples, for medium, 62.5% times 16 pixels is 10 pixels, which is the value we want. And for very large screens, 62.5% times 24 pixels is 15 pixels. Again, the 24 pixels comes from the very large font size. So by using 62.5% for the different font sizes in the browser, we're multiplying each of them so that if someone were to go change their browser font size, everything still scales nicely. So let's go and update that inside VS Code. I'm just going to change our 10 pixels to 62.5%. If I refresh, nothing will happen. But now we've ensured that if the font size of the browser changes, this will scale accordingly. And just to demonstrate this inside the browser, let's go to the settings. I'll go to appearance. For the font size, let's change it to very large. You can see the text goes very large. It's taking the browser's very large font size, which is 24 pixels, and multiplying it by 62.5%. Let's go change it to very small, and you'll see everything goes much smaller. The very small font size value is 9 pixels, so it's taking 9 pixels and multiplying it by 62.5%. All right, I'm just going to change it back to medium, and I want to show you what happens if we left this at 10 pixels. As you can see, there's been no change because 10 pixels is the same as 62.5% times 16 pixels, which is the medium case. But watch what happens now. If I go change this to very large, there's no change. And if I change it to very small, there's also no change. And that's because doing this is overriding the font sizes you set in your browser. So that's why using a percentage value is a lot better. Let's now take a look at some REMs guidance. REMs are commonly used on font size, margins, and paddings to create fully responsive web pages. I have this homepage on the left over here. We have some padding applied above the main heading, and you can see the font size is quite large. Looking now at the mobile version of this page, the padding over here reduces, and the font size also reduces. And as I've mentioned, when you come to learn about responsive design with media queries, all we're going to be doing is changing the font size of the root HTML element for different screen widths, which will automatically adjust the font size, padding, and margin for different screens. You can learn all about responsive design using REM values inside media queries in my video in the description below. Let's now look at EMs. Now, EMs are not as frequently used as REMs, but we do need to go through them, as you will see them out there in the wild, and you also may want to use them in your own project. EMs is a relative unit that is more context-specific compared to REMs. When I say context-specific, I just mean closer. As you know by now, inside an HTML file, you can have many levels of nesting. REMs are relying on the root HTML element, which could be many nested layers above the element you're styling. EMs are not based on the root element. They're based on an element much closer to the specific element that you're now styling. Now, there are two main use cases of EMs. The first is for typography, where the element you are styling is relative to the font size of the parent. Properties you would use include font size, align height, and letter spacing. And again, I really want to highlight that we're relative to a parent now, and not the root HTML element. Our reference point is much closer or context specific. So let's go play around with this inside VS Code. All right, so I've gone ahead and set up a new index.html file. I've created a div, which has a class feature1. I have an h1, which has a class feature heading. I have a paragraph, which has a class feature paragraph. And I have an anchor tag with the class feature button. So let's move across to app.css. I'm going to select feature1, which again is our parent element. And I'm going to set its font size as 10 pixels. I'm going to select the feature heading, and I'm going to give it a font size of 2ems, which is 2 times the 10 pixels. As we discussed earlier, ems is based on a parent element's font size. Because I'm setting this parent element font size to 10 pixels, the font size of the heading will be 2 times 10, or 20 pixels. Let's go set some other properties nested inside the div. We'll select the feature paragraph. Let's give it a font size of 1em, so 1 times 10, which is 10 pixels. And let's select the feature button, which is that anchor tag. We'll give it a font size of 0.5ems, 0.5 times 10, which is 5 pixels. Let's also just give it a background color of light blue. All right, let's check this out in the browser. So you can see our heading, paragraph, and anchor tag over here. Let's just go confirm their sizes. I'll open up DevTools. I'll select the heading. You can see its font size is 2ems. And if I go to computed, you'll see the font size is 20 pixels. That's 2 times 10 pixels we set on our parent element. Now, if I go change the font size of the parent element, so let's go make it 20 pixels, you'll see all the values will double. So now the font size is 40 pixels of the heading. Now, just to really highlight that ems are based on a parent as opposed to the root element, let's go back into index.html. I'm going to copy this and paste it here. And I'm going to update this class to feature2. Inside app.css, I'm just going to change this back to 10 pixels. And I'm going to go select feature 2 and give it a font size of 20 pixels. And these styles are still being applied to the content inside both feature 1 and feature 2. So let's check this out in the browser. So what we can see here, because the feature 1's container has a font size of 10 pixels, whereas our feature 2 container has a font size of 20 pixels, the elements in here are effectively double the elements in here. Because features 1 font size is 10 pixels, whereas feature 2's font size is 20 pixels. Now you just wouldn't be able to do this with rems. Just to demonstrate this, I'm going to remove these styles. I'm going to get our HTML root element. I'm going to set its font size to 10 pixels. And then I'm just going to update these all to rems. If I refresh, you'll see both feature 1 and feature 2 are now the exact same. And that's because they're all being based off the single HTML root element. Whereas before, I was able to size the features differently based on the parent element's font size. Now, in addition to typography, we can apply ems to other properties, and these are relative to the font size of the element itself. Common properties include width, height, margin, and padding. That is, box model properties. Let's play around with these in VS Code. I'm back inside the index.html file we were just in earlier. I'm going to go remove all of this. I'm just going to add a single anchor tag. For now, I'll point it to Google. I'll just have the text, click me. Inside app.css, I'm going to remove all these styles. I'll select the anchor tag. Let's give it a font size of 50 pixels, padding of 20 pixels, top and bottom, 40 pixels left and right. Let's give it a border radius of 20 pixels. Let's give it a background color of light coral. And for the box model properties to display properly, we need to change its display property to inline block. All right, let's check this out in the browser. So as expected, we have a button component. Now, this is obviously quite a large button. If I had a smaller button in the application and I wanted the font size to be 10 pixels, if I only change the font size and refresh this, you'll see this just looks quite bad. There's way too much spacing around the element. So instead, I can do this. So let me first just change this back to 50 pixels. So a better approach would be allowing us to scale the button based on the font size. So to do this, we can use the font size of the anchor tag set here and apply M properties to the padding and border radius. And that way, when we change the font size, these two properties will scale accordingly. So for the padding, we have a reference font size of 50 pixels. For 20 pixels, we would need to change this to 0.4 M. 0.4 times 50 gets us back to 20 pixels. For 40 pixels, this would be 0.8 M. 0.8 times 50 pixels gets us back to 40 pixels. And again, 20 pixels is 0.4 M. So if I refresh, there won't be any changes. But watch what happens as I change the font size now. Let's go to 20 pixels. I'll refresh, and you can see the button is scaling correctly with the font size. The padding and border radius has scaled nicely. So we can put any font size value we want here. Let's go make it huge at 100 pixels. You'll see again, the proportion of the border radius and the padding top and bottom is scaling with the font size. So let's now take a look at some EMS guidance. EMS provide a higher level of precision for styling smaller components, as sizing is based on font size of the element itself. So like we just saw, we can have button padding based on the font size of the button itself. Now, EMS do provide a lot of precision, but the truth is, using rems will make very little visual difference. In the major project we're going to be working on soon, we're only going to be using rems and not EMS. And I suggest when you start out, you also just use rems. When you become a bit more advanced with CSS, and you really want precision styling, feel free to use EMS. And just to show you that using rems is totally fine, let's take a look at this application. I'll open up DevTools, and let's go click around on some different elements. We'll click on this heading, and you'll see its font size is set at 3.7 rems. If I go to a component like a button, which is a good candidate for using EMS, you'll see again, box model properties like border radius and padding are still set in rems. So here's an example of a professional working application that's just using rems everywhere. And as I said, we're going to be doing the same, and I wouldn't worry too much about EMS. So let's wrap up the theory of this video by building a summary card. Now for this summary card, I want to focus on rems and EMS in the context of CSS units. So let's first look at the more commonly used units in CSS. They include pixels, which are using the properties listed here, percentages, which are using the properties listed here, and rems, where rems is commonly used on text, margin, and padding. Let's now look at units used for specific cases. They include VH units, VW units, and finally EMs, which can be used on margin and padding. But as we've discussed, REMs are totally fine to use. Now in the description below, I have a comprehensive video going through the topic of CSS units, where I cover all of these units: pixels, percentages, REMs, EMs, VH, and VW units. But I just wanted to finish this video off by providing some context of how REMs and EMs fits into the bigger topic of CSS units. Now that you've mastered the theory so far in this video, it's important to understand how we can use it in a real-world web application. For this part of the video, I recommend you download the starter HTML and CSS files in the description below and code along with me. We will be working on the homepage for a major full-stack web application called Quill, which you can learn more about in the description below. This project is part of my CSS full course, where we build the Quill homepage from scratch. You can join me for free in my CSS full course on YouTube by clicking in the video appearing in the top right now. Alright, so let's go add REMs to the Quill homepage. Now up until this point in the project, I was using pixel values for font size, margin, and padding. So we will now go and update all of those values to REMs. So all font sizes will be changed to REM, all paddings will be changed to REM, and all margin will be changed to REM. So all we're going to be doing now is updating a whole bunch of values, so we can use REMs moving forward. So I'm back inside the app.css file of our project. We're going to scroll down, and the first thing I need to do is select the HTML root element. We always want the universal selector to come first, and we're going to pop the HTML root element underneath this. Like we saw earlier on, we're going to set the font size to 62.5%. This is basically the same as 10 pixels, and as we spoke about earlier, this is better practice because if someone updates the font size in their browser, like my mum, to something much larger, we're not overriding that value, with say a font size of 10 pixels. So that's the first thing we need to do. Now we need to go change a whole bunch of pixel values. I'm also going to be highlighting values we don't want to change. In the container, 1200 pixels, we don't want to touch that. We only want to be applying REMs to things which we do want to scale. The reason we have max width at 1200 pixels is for much larger screens. As soon as we start moving down to smaller screens, we want to use REMs. But for a large screen size, there's no need to apply REMs because it's only being used for one case, and that's to ensure our content doesn't spread too wide on larger screens. If you want to learn more about using max width on a main page wrapper, you can check out my video on containers in the description below. Anytime we're using small values of pixels, like letter spacing, there's also no point in using REMs, so we're going to leave this as -2 pixels. All the font sizes, we definitely want to update to REMs. So I'm going to change 62 pixels to 6.2 rem. 48 pixels will now become 4.8 rem. 40 pixels will become 4 rem. 32 pixels, 3.2 rem. 24 pixels, 2.4 rem. Now for our paragraph, we're also going to update this to 2 rem. Our anchor tag will be 1.6 rem. Our small text also needs to change to 1.2 rem. So we've updated the global styles. Let's now go update our different components. The font size in the button, we want to change to 1.6 rem. The padding we want to change from 15 pixels and 30 pixels to 1.5 rem and 3 rem. The border radius of 8 pixels, we're just going to leave. As we've seen earlier, border radius is a property we just keep in pixels. It's such a small value that rems has very little significance. For the different states of our button, we can see 2 pixels is being used on the border. And again, we're not going to go change that. It's such a small value. For the highlight, we're going to update the padding here to 0.5 rem and here to 1 rem. Again, border radius we're not going to touch. Now for small images, like our logo, medium and small, we're just going to leave those as fixed widths in pixels. As we saw in the guidance earlier, we continue to use pixels for logos and icons. Let's now go down to the different sections of our page, where we'll be changing a lot of margin properties. We'll change our 200 pixel value here to 20 rems. In the hero section, this will now become 30 rems. 10 pixels will become 1 rem, and 50 pixels becomes 5 rems. In the features section, 300 pixels will become 30 rem. The margin bottom here will now become 8 rem. 20 pixels will change to 2 rem. And again, the max width here, I'm just going to leave it 400 pixels. It's the exact same guidance with our container. When using max width, that's just ensuring an image doesn't go too big for a certain screen size. As soon as we reduce the width of the browser, that disappears anyway, and width 100% takes over. We don't need to apply rem values for max width. If this setup is new to you for how to ensure images adjust with screen size, you can check out my video on percentages in the description below. Going down to our CTA section, we're going to update 300 pixels to 30 rems. And for our CTA card, we're going to leave the max width at 1000 pixels, but we'll update the padding to 10 rem and over here to 20 rem. The border radius, again, we're just going to use pixels. Scrolling down, we're going to update 30 pixels to 3 rem. And in our footer, we're just going to leave the width of this social media icon at 20 pixels. So let's check this out in the browser. So there's been absolutely no change. All I've done is updated our pixel values to the equivalent rem value. If I open up DevTools, let's click on the heading. You can see its font size is 6.2 rems. If I go to Computed and check the font size, it's 62 pixels, which was the original font size we set using pixels, but we've now changed to rems. So all we've done here is update the font size, padding, and margin to rems. So later on in the project, when we go and use media queries to make our page responsive for different screen sizes, all of these values will easily change when we go and update the font size of the root HTML element. To check this out, you can watch my video on media queries in the description below. Now, just to give you a taste of this, currently the root element has a font size of 62.5% or 10 pixels. If I update this to say 50 pixels, which would effectively be 50% times 16 pixels, or 8 pixels, watch what happens as I refresh the browser. All the font size, margin, and padding has now scaled. Let's change this to a much smaller value, like 20 pixels. Okay, again, you can see all the margin, padding, and font size has all scaled down. Now this obviously looks awful, but I just wanted to demonstrate that by just updating this single value now, the font size of the root element, it automatically updates all the padding, margin, and font size within the design. Okay, let's just change this back to 62.5%. If you enjoyed this style of teaching and are looking at mastering CSS, you can join me in my CSS full course, which is available for free on my channel. It's the world's most detailed CSS full course designed for complete beginners and covers everything you need to know to code CSS at a professional level. In the course, you'll experience the same high-quality teaching and build the Quill homepage from scratch. Join me today and also make sure to subscribe to my channel to stay in the loop with new releases. See you in the CSS full course.